All right, here we go. 4.2. Okay, 4.2, page 1. Okay, so we're going to talk about least squares regression now. So in 4.1, we talked about how to determine if there's a linear correlation between variables. If there is a linear correlation, then you might want to figure out, well, what is the line that fits that that distribution? What is the best fit line? And so let's get started, right? Let's talk about how to do this. Now, this is going to be a blast from your algebraic past for sure, right? So we're going to review a little bit about how you find the equation for a line. And again, you probably did a little bit of this in ALEX when you were going through the ALEX course. So recall, the slope of a line, right? That's the rise over the run, right? So the slope of a line that goes through 2 points, x1, y1, and x2, y2, is y2 minus y1 over x2 minus x1. Right? So y2 minus y1 over x2 minus x1. It's the rise, so the change in y, over the run, so the change in x, right? So rise over run. The point slope form of a line is y minus y1 equals m times x minus x1, where m is the slope, right? Again, and m is the slope. Now that equation isn't particularly, we don't love it when lines are written in that format. We prefer it when lines are written in y equals mx plus b form. But this is a good place to start in order to get your line into y equals mx plus b form. By the way, y equals mx plus b form is called the slope-intercept form, right? So the slope-intercept form of the line is y equals mx plus b, where m is the slope, right? So m is the slope and b is the y-intercept. In other words, the place where the line crosses the y-axis. Now, if none of this is sounding particularly familiar to you, don't worry about it too much. We're gonna be using StatCrunch to find the equations for lines and all of that. But for those of you who do remember a little bit of algebra, I wanted to take you through an exercise where we try to come up with a line that fits the data that we looked at back in section 4.1. Right? So here's that same data, right? The absences versus the final grade. It's the same data that we drew a scatter plot for in section 4.1. So here's the scatter plot that we drew in section 4.1, right? And we're asked to find an equation for a line that fits the data here. Okay, so again, I'm taking my 4.1 notes, and I'm not going to try to redraw this. I'm just going to use the scatter plot that we already made. And one way that I can find an equation for a line that fits this data would be to choose 2 points here whose straight line seems to be a pretty good fit for the rest of the data. And then I can use those 2 points to find the equation for the line that goes through them. So, so just kind of eyeballing it here, it's like if I choose these 2 points down there, that would give me a straight line, but all of the points, all of the data points are above that line, so that's probably not a very good fit. But maybe if I take these 2 that are sort of like right in the middle, that might be a pretty good fit. So I'm going to use those 2 points as my line, right? I'm going to use those 2 points to find the equation for my line, right? So I'm going to do something like that. Okay. So I want to use these 2 points. Now, what are these 2 points? Well, this one right here, this must be the point 12, and then like 60-ish. So looking back at my table, the only point that has an x-coordinate of 12 is this one right here, 1258. So that must be that point, right? 1258. This point right here, looks like it has an x-coordinate of 6. So I'm guessing it's the point 682. That looks about right. So that's the point 682. So those are the 2 points that I'm going to use. 682, and 1258. Okay. So those are the 2 points that I'm going to use to try to come up with an equation for a line that fits this data pretty well. Okay. So this point I'm going to call x1, y1. Right, so here's x1, here's y1. This point I'm going to call x2, y2. So here's x2, here's y2. Okay. And let's see if we can write an equation for the line that goes through these 2 points. So the way that we do that is, first of all, find the slope of the line. Okay. So we can do that by using the formula we just wrote down, right? M, the slope, is y2 minus y1 over x2 minus x1. Remember that I called this one x1, y1, and this one x2, y2. So y2 minus y1 would be 58 minus 82. x2 minus x1 would be 12 minus 6. Okay, now we can use a calculator, although this seems like it's going to work out kind of nice. What is, let's see, 58 minus 82 is negative 24. So this is negative 24 over 12 minus 6 is 6. Oh, that comes out beautifully to negative 4. Look at that. Okay, pretty nice. So there's our slope. Now to get the equation for the line that goes through these 2 points, we can use the point-slope form of the line. We'll plug in some values, and then we'll simplify it so that it's in slope-intercept form here. Okay, so I'm going to say, okay, so the point-slope form, y minus y1 equals m times x minus x1. And by the way, there's more than one way to do this, right? So for some of you, this process may not look all that familiar because maybe you did it differently in your algebra class in the past. Again, I wouldn't worry about it too much. I'm not going to ask you to do this on a test or a quiz or something. I'm just doing it kind of for the sake of argument, right? To kind of show you how one might go about finding the equation for a line that seems to fit the data. But we're going to do this in StatCrunch here in a second. And so I'll show you how that works. But anyway, so coming back here, we're going to plug some stuff in. Again, I called this point x1, y1. Although you could use either of these points, it doesn't really matter for x and y right here. But I'm going to plug stuff in. So I'm going to say y minus y1, which is 82, equals m, negative 4, times x minus x1, which is 6. And then what I want to do is simplify this and solve for y so that it's in slope-intercept form. So I'm going to say y minus 82. Distribute the negative 4, I get negative 4x plus 24. And then add 82 over to the other side. And I get y equals negative 4x plus 106. And there it is, right? There's the equation for my line. The question is this the line that best fits the data? You know, maybe if we had chosen 2 different points, we would have gotten a better fit. How do you even determine that, right? How can we tell if it is or isn't? Well, one of the ways that, well, to make a long story short, the line that's going to best fit the data is going to be the line that minimizes. So I'm going back to this is my scatter plot from 4.1. The line that best fits the data is going to be the line that minimizes the distance between the point and the line. So if you look at all of these distances, right, if you look at all those distances from the point to the line, and you look for the line that minimizes the total distance of all those points, that's going to be the line that best fits the data. And loosely speaking, that line is called the least squares regression line, which is why this section is called least squares regression. Okay, so it's the least squares regression line. That's the line that's going to best fit the data. How do you find the least squares regression line? Well, you take a course in linear algebra, and then you learn how to find, you learn how to do least squares regression. Obviously, linear algebra is a course you would take like after you've completed the calculus series. So obviously, like most of us haven't had linear algebra. So we're just going to let StatCrunch do it for us. And that's as much as I can say about that. But real quick before we go on to the next page, it is kind of interesting to think about what this line represents. In particular, it's interesting to think about what the slope represents and what the y-intercept represents. So again, x was the number of absences, and y was the final grade that you ended up with in the class. The slope is telling us what the change in y is for every change in x. In other words, it's telling us that for every increase in absence, so for every additional day that you miss class, your final grade is going to drop by 4 points. Does that make sense? So that's what the slope is telling us, right? So for every additional day you miss class, your final grade decreases by 4 points. So that's kind of interesting. We'll talk about this a little bit more in a second. And you might have some homework questions that ask you things like that. Like it'll ask you to interpret the slope or something along those lines. And that's what they're asking you to try to see from the equation and how it relates to the actual example you're looking at. The y-intercept, now this is also interesting. The y-intercept here is it's where the line crosses the y-axis. Okay, if you think about it, when the line is crossing the y-axis, right? So when you're at that point right there, the x-coordinate is 0. Right? Your x-coordinate is 0 at that point. So the y-intercept tells you what happens when x is 0. In this case, x is the number of absences, right? So if x is 0, then that means you had perfect attendance. You never missed class, okay? And what this line is predicting is that if you never miss class, if the number of absences is 0, you could plug in 0 to figure out what your final grade y would be. And if you plug in 0 here, you get y equals -4 times 0 plus 106. Well, -4 times 0 is just 0, and 0 plus 106 is 106. So what this line is predicting is that if you miss class 0 times, you'll end up with 106% in the class. And that kind of shows you some of the limitations with the predictions that we can do, because obviously it's not possible for you to end up with 106% in a class, right? Unless that class had a lot of extra credit. Like in our class, you could end up with more than 100%, but not that much more. You could end up with, like if you did absolutely perfect all semester, you might end up with like 101% by the end of the semester. 106 is just not possible. But the reason that we're getting this impossible result for x equals 0 is because we didn't have any predictions here that told us, or we didn't have any data rather. We didn't have any data here that told us what a final grade would be for 0 absences. So zero absences is outside of the scope that our model is usable for, right? So really we can only use this model to predict things, to predict grades for absences between 2 and 15, since that's the smallest and largest values in our data set. Okay, otherwise if you try to apply this model to things that are outside of our experience, then you're going to end up with results that are meaningless, kind of nonsensical. Okay. Anyway, but that's just kind of interesting. We'll move on to page 2, and I will start a new video.